In this lesson, I'll show you how to find the volume of solids using the shell method and disk method. The question reads, find the volume generated when the first quadrant area, bounded by y is equal to x squared, the y-axis and the lines y is equal to 1 and y is equal to 4, is rotated about the y-axis. We are expected to find the volume using the disk method and using the shell method. I'll start off with part A, which is the disk method, and that uses the following formula where volume is equal to pi times the integral between a and b, the radius to the power of 2 dh. Using this formula, let's set up our question by saying v is equal to pi, and our bounds are 1 and 4. Our radius will be the function itself. Now, since it's being rotated about the y-axis, we have to rearrange our equation so that it's in terms of y instead of x. So my equation is y is equal to x squared. I'll solve for x, where I get x is equal to the square root of y. And I'll substitute that where we see the r. So the square root of y to the power of 2. And since it's in terms of y, we have to write down dy. I'll simplify this part first. Pi times the integral between 1 and 4. This becomes y dy. Now I have to integrate y. That's not hard to do. We have pi times y to the power of 2 over 2. And this will represent our volume after we evaluated it at 4 and 1. Starting with 4, we have 4 to the power of 2 is 16, so 16 pi over 2 minus 1 to the power of 2, that's pi over 2. Let's find out what this is equal to. 16 pi minus pi is 15 pi over 2 cubic units. Alright, so that's the answer using the disk method. Moving on to the shell method, this method is completely different from the disk method. The shell method is about vertically layering rings defined by 2 pi times x, where x is the radius of the ring of varying thickness and the shape f at x. Also notice that the formula is in terms of r, whereas in the disk method, r and h had to be expressed in terms of x and y. If you look at the cylinder that's been placed within the shape that we're trying to find the volume of, the radius is facing the horizontal. So our bounds have to be the bounds of the horizontal, not the vertical, even though they're expecting us to find the volume between 0 and 4. To find the horizontal bounds, what we have to do is take our bounds of 0 and 4 that they tell us in the question and substitute them into the formula. The formula is y is equal to x squared. So if I substitute y is equal to 0 and y is equal to 4, I'll end up with my bounds. Substituting 0 into here, I end up with x is equal to 0. That's one of my bounds. And substituting 4 into here, I end up with 4 is equal to x squared. Square rooting both sides, I end up with plus minus 2 is equal to x. Obviously, I'm only going to choose the positive one because it's in the first quadrant. So these are my bounds for a and b. That's one big difference between this method and the previous. We have 2 pi times the integral between 0 and 2. Now our radius will be x, as shown in this diagram here. And another way to think about it is pretend that this cylinder, this thin-walled cylinder, was hitting the bottom here. So this radius is always representing the x, especially since the shape has been rotating about the y-axis. We know the height of this cylinder in particular, and this serves for all cylinders that fit within this structure, is the distance from here to here, which is 4, and that is equal to the height of the cylinder, which we'll call y, plus this unknown height that's left over. So if we bring this y over, we end up with 4 minus y is equal to h, and h can be represented as 4 minus y. I know what you're probably thinking right now. How can you integrate when you have x and y? Well, remember, y is equal to x squared, so we can replace this y with x squared. V is equal to 2 pi, the integral of 0 to 2, x, bracket 4 minus x squared dx. It's in terms of dx because of what I mentioned earlier, the radius here moves along the horizontal. Now I can integrate by first expanding 4x minus x to the power of 3 between 2 and 0. Let's integrate this. You should end up with 2 pi square bracket 2x squared. The antiderivative of that is this, minus x to the power of 4 over 4. And now we will find out what this is at 2 and 0. Let's go ahead and do that. The volume is equal to 2 pi square bracket 2 times 2 to the power of 2 minus 2 to the power of 4 over 4. And this should give us 8 cubic units. And there you have it. That is how to find the volume of solids using the shell method and disk method.